Okay, so today we're going to be focusing on our tricks that we use when we have logs. Now, these aren't just the log laws, they are the things that most commonly stop people from being successful when completing logs because they're just the facts that they forget. Okay, so let's start with number 1. Whoop. Drawer. Okay, let's go back to the thickness that we like. Okay, so first one that we're going to look at is this log law. Now, this is a log law, and it is log of any base. If we have a 1 in this position, it's going to be equal to 0. Now, the easiest way of remembering this one is to remember the reverse fact. Remember, if I rearrange this, I will take this log with base a to the other side, and it will become a to the power of 0 is equal to 1, which is a true statement because anything to the power of 0 is always equal to 1. So, next log law that we've got is if I have a log with any base and it matches the number in this position, it's going to be equal to 1. Again, I can remember this one by rearranging this statement here. So if I capture this log a and take it to the other side, it will become a to the power of 1 is equal to, and this is what will be left on the other side, be equal to a. And you can see that that statement's true too. This is the power of 1 that's the same as the number that it was originally. Okay, the third log law. Log a. Now, if there's a 0 in this position, it's always going to give you a math error. Now, the reason why you're going to get a math error is, again, if I rearrange this statement, and instead of having math error, let's just say it's x for the moment. Okay, that is never going to be true. There is no value that a can take on where it will become 0 here. Think about it like this. If I have a to the power of 1, let's do this with numbers. If I have 2 to the power of 1, that's 2. 2 to the power of 0 is equal to 1. 2 to the power of negative 1 is actually the same as saying 1 over 2 to the power of 1, which is just the same as saying a half. If I have 2 to the power of negative 2, then I can say that that is the same as saying 1 over 2 squared, which is the same as saying 1 over 4. There is no point at which this thing will hit 0. It will get very close, but it will never actually touch it. So that's why this statement here will give you a math error. Number 4 trick, log a. So if we have a base a here, and I've got an m here, and it's got some power at the top there, I can think about it like I can capture that power at the top, capture him, take him to the front. So this can be expressed as n log a m. So this statement is the same as that. Now you're probably thinking, okay, that's cool, easy fact to remember. Why do I care about this? Now the real problem that happens with this sort of question is that when you're adding or subtracting logs, n must be a power. Okay, so I'd like you to take note of that when adding and subtracting logs, n must be a power. Okay, so let's look at an example of this. So when we're looking at something of this form, 2 log 3, 4 plus 2 log 3, 5. Now, the most common thing that I see that it is definitely not correct is that people will go, sweet, 2 plus 2 makes 4, log 3, and then 4 times 5 makes 20. Now, the reason why that is not correct is because if I think about it, this number is going to be different to this number on the end. If I've got 2 lots of A, I can't just add them to 2 lots of B. They don't have the same end, so they're not like terms, just like these are not like terms. So the correct procedure for this is to turn it back into a power. And then once I've done that, now I can treat my logs the way that I normally do, and it'll become log 3 bracket 4 to the power of 2 times 5 to the power of 2. So that would give me the correct answer, which is not equivalent to this. This is not correct. Don't do that. I see it all the time. Okay, next little trick that we've got. Trick number 5 is matchy-matchy your bases. So if I've got a log, and let's say that my base is 2, and let's say that the number I've got is 32. Now, very commonly, we try to match the bases so that they're the same so that we can add and subtract things. So when I say match the bases, I mean that if this is a base of 2 and this number is 32, I'm going to try and change it so that I end up with 2 to the power of something is equal to 32. Okay, so you can do this on your hands. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So 2 to the power of 5 is equal to 32, meaning that I can express this statement as log 2 to the power of 5. Now I've done that, you can see straight away that it's going to relate back to this trick up here. So as soon as I have this base match that number, it's equal to 1. And this number could come to the front. So if I re-express this as 5 log 2, I can capture this, cancel it out, and I'm left with my answer of 5. So it's a really handy trick to have so that you can express things in exact values without using your calculators. So if I was going to write that process in words, I would write it as match the base to the number and rewrite. So in this case, we rewrite the 32 as 2 to the power of something else. Okay, like I said, really common thing that pops up all of the time. Okay, so one last trick to go for this basic section, just about tricks that we use when we deal with logs. Okay, so this we'll call trick number 6. Now, trick number 6 is one that I hate because it's always in the external exams and I go over it so many times and people always forget it. Okay, so trick number 6. Why is it not letting me draw? Okay, it's when we have something that looks like this. Log with base 2, 81 over log with base 2, and we'll pick another number. Let's pick 9. Okay, so the reason why I hate this is people's first instinct is to do this. Log base 2, 81 over 9 like that. Now, the reason why that's not correct is for this statement to be true, I need to have log 2, 81 minus log 2, 9. Okay, if I have this written, that's what it's equal to, not if I have this divided by that. Okay, it's just like if I have 9 minus 2, that's 7, versus if I have 9 divided by 2, that's 4.5. Those answers are different, which is the same reason why these two things aren't the same. So the process that we need to do is we need to rewrite both numbers so that log AB matches in both. Now, we'll end up with powers above the B, which is fine. The powers above the B is what we're going to use as our answers because as soon as I have log AB the same in both cases, if they're dividing, that's going to leave me with 1. So let's look at this as the example. I can match 81 to 9 because I can say that 81 is just 9 to the power of 2. So log 2, 9 squared over log 2, 9. Okay, now I can take this one to the front, cancel that out, and now you can see that I'm left with log 2, 9 divided by log 2, 9. So that is like saying anything divided by itself is always equal to 1, which leaves me with my answer of 2. This one right here, this has been in the exam for the past maybe 2, 3 times that I've got a practice exam. Please make sure that you remember that one.